Welcome to the Math Record. Today I'll be covering the ICTM Regional 2015 Division AA Junior Senior A-Person, which I'll be covering questions 9, 13, and 14 in this video, and then questions 19 and 20 in the next. As usual, I'll scroll down all 20 questions in case you want to answer these by yourself, and then I'll give the answers at the end. So let's begin with number 9. So infinitely many nested squares are formed by connecting the midpoints of one side of one square in order to make an interior square. So I'm not going to read the rest of this, but basically it's just this picture that they're describing. So they connect the midpoint of each triangle, and then from that triangle they connect the midpoints of those, and then it goes on for infinitely, and we need to find the area of the shaded region. So they said in this sentence that the original square has length 2. So that means the area is 2 squared, which is 4. So the entire area of this big square is 4. Since we connect the midpoint to make the white square, which a bunch of other square that is nested inside. That means the first section of the shaded, so this part, this part, this part, and this part should all add up to half of the entire square. So since the entire square is 4, half of it is 2. So the area of this is 2. Okay, so now what's the area of the next shaded region? So since we took half of it, that means the inner square white, which with the nested also is a 2. So then half of that is 1. So the area of the shaded, so the area of this black square shaded inside plus this white and infinitely many nested is 1. So then half and half of that will be 1/2. So that will be the area of the next shaded. So and then from there, we have 1/2. So then 1/2. So you have to think about this logically now because we don't have the pictures to support anymore because they stopped drawing. We have 1/2 of the area, which is the inner white square. And then from that inner white square, we take a half of that to make 1/4, which would be the area of our black inner square. But then the black inner square also is like the second inner square where there's a white nest inside. So we have a half of a half. So we have 1/2 times a half, which is 1/8. So if you see this, we're going by a pattern. 2 times 1/4 is 1/2. 1/2 times 1/4 is 1/8. So we had to add up all those black regions. So it's going to be a summation from x equals 1 to infinity because this is going on forever because it's infinitely many nested squares, right, in the first sentence. And our first is 2 times our common ratio, which is 1/4 to the power of x. So this is an infinite geometric series, but just in a geometry form. So this is just going to be the first term, which is 2 over 1 minus the ratio. And this would be 3/4, so it would be 2 times 4/3, which is equal to 8/3. And that is your answer for number 9. And that's all you need to know. You just need to recognize it as an infinite geometric series in a geometry form. And then number 13. 2 square x plus 3 cube root y to the power of 4 is expanded and in decreasing powers of x. Determine the sum of the numerical coefficients of the terms in which the powers of x is a positive integer. So the power of x is a positive integer if square root x to the power of something is going to be an integer. So that gives us that since the square root of x is just x to the power 1/2, that means this, since it's power to 4, it could go to a power of 4, or it could be x 1/2 to the power of 2. And that's it. Those are the only ones that work. So when it's a power to 4, then basically you could just use the idea, the summation, where x is equal to um, 0 to infinity. It's just the binomial expansion. So it's just going to be 2, well, 4, because it's exponent 4, choose x, times the coefficient, which is x, which is 2 to the power of x, times our exponent of this, which is 3 to the power of 4 minus x. So we could just use this. So our x here is going to be 4. So we plug in 4 in here. Then we have 2 to the power of 4. 4 choose 4 is 1 times 3. 4 minus 4 is 0. So 3 to the power of 0 is 1. So that's just 2 to the power of 4 times 1. And then now this one's 2, so we plug in x equals 2 here. So 4 choose 2 times 2 to the power 2 times 3. 4 minus 2 is 2, so 3 to the power 2. So 2 times 2 times 2 times 2, that is equal to 16. 4 choose 2, that is just going to be 4 times 3 divided by another 2, so that's going to be 6 times a 4 times a 9. So what does this come out to? Well, that's 36. 36 times 6 is 216. So 216 plus your 16 is 232. And that is your answer for number 13. So you just need to know the binomial expansion. It's just that simple. Now number 14. The sum of all real angles from 0 to pi such that the graph of the function f of x cosine of theta times x squared plus sine of theta times x plus 1/4 cosine of theta has exactly one x-intercept may be rewritten as pi, k pi. Determine the value of k. So this only has one x-intercept. So using quadratic form is negative b plus or minus b squared minus 4ac over 2a. So this only has one x-intercept if this value is equal to 0. If this value is equal to 0, then it's just going to be plus or minus 0. So that's basically nothing. So there's only one possible answer. So this has to be equal to 0. So b squared minus 4ac has to equal 0. So your b is sine of theta, so sine squared of theta, minus 4 times a, which is cosine of theta, times c equals 0. So then this is just sine of 2 theta, sine squared of theta, minus cosine squared of theta is equal to 0. So that basically just give us that sine of theta and cosine of theta has to be equal to each other, or one of them is the negative version of something else. So basically, this only happens when it's at the 45 degrees. So it's only happen at power 4, or it happens at 3 power 4. So this is the 45 degrees, and this is the 135 degrees, right? So it's like halfway between this line and this line. So it's this line, and this line is halfway between this line and this line. And that's why they're equal, and you could cancel them out that way. So we have both of these. So we have pi over 4 and 3 pi over 4. So we have those two so far. So that's one of the conditions. So that's what happens when it's quadratic. So what happens if it's not quadratic? So if it's not quadratic, that means the x squared term, the coefficient has to be 0. That means cosine of theta has to equal 0. So cosine of theta only equals 0 when it's at 90 degrees or when it's at pi over 2. So that's pi over 2. And those are the only combinations that work. So add them together, 1/4 times 1/4 plus 3/4 is 1, plus 1/2 is 3 over 2. And that's 3 over 2 pi, but we're just looking for k, so that's just 3 over 2. So that's your answer for number 14, 3 over 2. And as promised, here are all the answers for all 20 questions. Well, thanks for watching, and I'll see you at the second part of this contest.